This video is for educational purposes only, and only competent persons should attempt this installation. Today, I'd like to show you one way to replace your existing old 2-prong receptacles with modern 3-prong GFCI receptacles per the 2020 NEC Code. Let's consult the NEC to see what it has to say about this. Here we are at NEC Code 406.4 2B. A non-grounding type receptacle shall be permitted to be replaced with a ground fault circuit interrupter type of receptacle. These receptacles or their cover plates shall be marked no equipment ground. An equipment grounding conductor shall not be connected from the ground fault circuit interrupter type receptacle to any outlet supplied from the ground fault circuit interrupter receptacle. C. A non-grounding type receptacle shall be permitted to be replaced with a grounding type receptacle where supplied through a ground fault circuit interrupter. Where grounding type receptacles are supplied through the ground fault circuit interrupter, grounding type receptacles or their cover plates shall be marked GFCI protected and no equipment ground, visible after installation. An equipment grounding conductor shall not be connected between the grounding type receptacles. Let's take a closer look at B. It says a non-grounding type of receptacle or receptacles. That's the old 2-prong receptacles that I'm going to be working with in an old 1960 house today. Shall be permitted to be replaced with a ground fault circuit interrupter type of receptacle or receptacles. That's what I'm going to do. I'm going to use multiple ground fault circuit interrupter type of receptacles, plural. To accomplish this, I'm only going to be using the line portion of the GFCIs. All my wires are going to be going to the line portion, not the load portion. And I'm going to be using Leviton Slimline GFCIs because they're smaller and slimmer than any other brand of GFCI.
Today I'm going to be changing out the receptacles of a circuit in a 1960s house. Some of the receptacles are still the 2-prong and some are 3-prong, but I'm going to be changing out to ground fault circuit interrupters for each one. This circuit originally had ungrounded receptacles, and I'm not sure what I'm going to be finding when I take out each of the receptacles, but I doubt that there's a real ground for most of them anyway. Perhaps a ground wire has been run to one or two of them. We'll be finding out. I'm going to be using the GFCI receptacles for each one. I made another video where I just put one of these GFCI receptacles in the most upstream position, and it protected the rest of the circuit. And the rest of the circuit I used grounding receptacles, modern grounding receptacles. That's a more economical way to do it. If you use the GFCIs in each and every location, that's going to cost you more. And also, you have to wire it correctly. But that's not a problem because I'm going to show you how to do it. This is my ideal transmitter for the circuit breaker finder set. We'll plug it in, and we find out that it has open ground, which you have to expect because it's not a grounded circuit. So I'm going to be using, see, this is the transmitter, and this larger piece is the receiver. And what I'm going to do is I'm going to go to the load center. I'm going to find out what circuit this is. I'm going to turn off the circuit breaker, and then I'm going to go around and find out all the receptacles that are off. And that will find the circuit that we need to be replacing the receptacles on. Okay, this is my receiver. I'm going to turn it on and let it warm up. Okay, I'm going to go over all of the breakers. You just let it chirp. It's looking for relative strength. Here it is right here. That's it. So you can see that there's no more lights on the transmitter. So we have selected the correct circuit breaker to turn off. So this is one of the receptacles on the circuit. So for each receptacle I find that is off right now, which shows that it's on the circuit, I'm going to put a piece of blue tape above it, and that will identify all the receptacles that we're going to be replacing. Okay, let's test this one out. And that one's off too, so that's part of the circuit. So I'm going to put a piece of blue tape right up above it, like that. Okay, that's the second receptacle on this circuit. Okay, we'll test this one out. That one's off, so that's a part of the circuit we're going to be working on. And by the way, don't be fooled just because it has 3 prongs. It's part of the original 2-prong receptacle circuit. It may have a ground in there somehow. We'll just have to find out, but it's part of the circuit. Here's another one, and it's off as well. So this is part of the circuit, and it also has a 3-prong receptacle, but don't let that fool you. So that's 4 so far. Okay, here's another receptacle, and it's off. So this is part of the circuit. I don't know what's with all these 3-prong receptacles. We'll find out though. Okay, this one's off. All right, there we go. This is in an adjoining bedroom, so we'll find out. I've identified 4 receptacles in the living room and 2 in the master bedroom as being on this circuit. And that's all I could find. So there's 6 receptacles on this circuit. This one is closest to the main panel, so this is the one that I would guess would be most upstream. So I'm going to make a test though. This is my Sure Test circuit analyzer, and I'm going to go ahead and plug this in here. And it's interesting. It says it's grounded. See, in the middle one there, it says it's grounded. It's not a fake ground or anything. So it's 121.5 volts. And here's what I'm really interested in. Voltage drop at 15 amp load. See, there's the 15 amp load right there. You press this one time, you get a 20 amp load. So the voltage drop increases. You press it again, it's only a 12 amp load. So it decreases. We'll just test it at a 15 amp load, and we get 4.5% voltage drop. And the actual voltage with this load on it, voltage load, this VL,
is 115.6 volts.
So it's 4.5%. I'm going to write that down. Voltage drop, big V, little d.
Then I tested the outlet that was second closest to the main panel. You see, that's my technique of finding the next downstream receptacle. I'd say, okay, which one is closest to the main panel? So this one is the next closest to the main panel, and it tested out at 6.5% voltage drop with 113.1 load of voltage. But you got to remember, that's a 15 amp load. That's like running a skill saw at startup. That's a big load. You say, okay, that's a lot of voltage drop, but that's under load, okay? That's different from not having any load. The receptacle that was third closest to the main panel tested out at 8.9% voltage drop with the 15 amp load. Here's the receptacle that is fourth farthest from the main panel. It is testing out at 10.1% voltage drop with a 15 amp load. The receptacle that is fifth farthest from the main panel shows a 12.4% voltage drop with the 15 amp load. And the receptacle that is very farthest from the main panel shows a 13.5% voltage drop with the 15 amp load.
Okay, I've turned off the circuit breaker, and you can see that circuit breaker's off because there's no lights on there. And also, you can test with your voltage detector as a double check. So the electricity definitely is off here. So now I'm going to remove this receptacle. And this did test as having a ground. So that should be interesting. 4.5% voltage drop. That tested out as the lowest voltage drop with the 15 amp test. So this is the closest receptacle to the main panel, and it has the lowest voltage drop. That tells me there's like a 99.9% chance that this is the most upstream receptacle of this circuit of 6 receptacles. That would be very important if we were just doing one GFCI and then the rest grounding receptacles. But since we're doing all GFCIs, it isn't that important, but it is interesting. And I am going to be trying to make excellent connections so that I hopefully can get this voltage drop down on each of the 6 receptacles. So my method of removing these is just to spin off the screws.
This receptacle does have a ground wire, and it does have a proper grounding screw attached to the metal box, and the whole system has this kind of grounding system. I think that the reason why this particular box was grounded with the old style grounding is that it is on an exterior wall. The other side of this receptacle is an exterior wall, so they probably chose to ground this particular box.
Okay, I've got this box vacuumed out, and I also took off some of the paper. There's excess paper sometimes you find in these old receptacles with this old wire. Just pull this paper off. So we got 2 neutral wires and 2 black wires and 1 ground wire, which we're going to use. I'm not going to continue this ground wire on to another receptacle because that would be breaking the code, but I don't see why I can't use it. I will mark this receptacle as a non-grounded receptacle, but it's going to have a ground. I don't think this ground would meet today's code, but you might as well hook it up. This is a Wago lever nut, and what I'm going to do is I'm going to take and put this neutral wire in there, and this neutral wire in there. Okay, and then I have a pigtail right here, which I'm going to put right in there like that. Okay, so this is going to go to the GFCI. Now, this is another wiggle lever nut, and I'll put this in here, click it down, put this in here, all the way. Got to make sure it goes in all the way. Okay, all the way in. Click it down. And then here's a pigtail that I prepared. Put in there all the way and click it down. Here's the GFCI. So the first thing we're going to do is hook up the ground. So we're going to take this ground and put it right in the terminal area there and tighten that on very securely. The neutral wire goes to the side with the longer slot and the silver terminal. So we're going to put it right down here at the silver terminal, and I'm going to tighten it down securely. And now the black hot wire goes to the bronze colored terminal and tighten it down securely. So what I've done is I've taken the cable that is the incoming cable, the one that's hot all the time, and hooked it together with the cable that's leaving this box going to the next one, and put a pigtail to the GFCI. In this way, if something happens to this receptacle, it gets mechanically damaged or something, the current will still be able to come into this box and leave this box. So that's why I'm running it this way. And the next thing I'm going to do is put a wrap of electrical tape around this GFCI. And I'm going to push the wires back into the back of the box
and install the GFCI.
And it's time to put the cover on. Now we're moving on to the second receptacle on the circuit, and this one is second farthest from the main panel. I guessed that this was number 2, and it is, according to the voltage drop. And you need to clean these things out a little bit. All right, this is a push-in type receptacle, so I'm just going to go ahead and cut all these wires.
Now I'm going to strip the ends of the wires with my Knipex electrical installation tool.
So we have 2 neutral wires, 2 hot wires, no ground wire. This is a 3 connector wiggle lever nut. We put 1 neutral wire all the way in, close it. Next neutral wire all the way in, close it. And here's a white neutral pigtail that I've prepared. Put that in there. Here's a black hot wire pigtail that I've prepared. Put it all the way in there. Click it down.
Now I'll connect the white neutral pigtail to the silver terminal of the GFCI, that's the neutral side. And I'll tighten down the unused green grounding terminal. Now I'll put the black hot wire to the bronze colored hot terminal and tighten it down securely. I'll put some black electrician's tape around the device for safety, and then I will install the device. This is the 3rd receptacle on the circuit, and it is reading that it has a ground. So we'll have to check this out. And notice how dirty it is. After I get all the wires undone from the receptacle, I'm going to vacuum this box out.
And this one has a ground wire. This box is back to back with the kitchen. And the kitchen has a ground wire running to the back of the metal boxes. So I think that they ran one to this because it was easy to do. Even though it's in a living room, and they don't usually have ground wires in the back of the boxes in the living room. And this one it does. So this has a ground wire attached to the box. So we got a cable coming in, that's a black and a white, and a cable going out, that's a black and a white. We're putting in a much wider receptacle, so you need to clear out any plaster that's in the corner. Here's the ground wire.
Then I'll wire and install this 3rd GFCI just like I did the previous 2. I also installed the 4th and 5th GFCIs in the same manner. The 6th and last GFCI only had 1 cable coming to it, so no pigtail was necessary.
I have turned the circuit breaker back on, and I have plugged in my ideal transmitter, which is also a really good GFCI receptacle tester. And you see, it reads 2 green lights, which is the indication for correct wiring. So it's showing a ground. Now, the ground that's in there is, it works as a ground, but I'm not counting it as a ground. You see, I put a little sticker on here that says no equipment ground. That's because that ground isn't going to meet code. It's a ground wire that goes to the back of a metal box, and then a green wire comes out from there to the receptacle. I've had a discussion with my local inspector about this, and this is what he wants me to do. He wants me to hook those up if it's available, but then put no equipment ground because it doesn't meet today's codes. So if we put this back in, I can test this GFCI, and it does work. And reset, that works. And it's showing 4.4% voltage drop, whereas it was 4.5% voltage drop previously. So the voltage drop with a 15 amp load has improved a little bit by putting in the new receptacle. I'm at the 2nd receptacle on the circuit, and I've had a pleasant surprise. This receptacle is now testing out as correct wiring, including a ground. And what happened? You see, these receptacles have what's called a self-grounding clip right here. And if the metal box is grounded, has what you need to create a good ground. Once again, I'm going to put on the no equipment ground sticker because the ground doesn't meet today's codes, but there it is as a ground. And let's test it out. Okay, it works good. Reset it. Okay, and this one is now reading 6.3% voltage drop as compared to 6.5% voltage drop previously. So putting in the new receptacle and doing good connections, good tight connections, has reduced the voltage drop down from 6.5 to 6.3 at a 15 amp load. Here we are at the third receptacle on the circuit. It's showing correct wiring, and it had 8.9% voltage drop, and it now has 8.2% voltage drop. Here we are at the fourth receptacle on the circuit, and this one is showing open ground, which is what you would expect. We got really lucky with the other ones finding a grounded box. This one is just kind of a normal 1960s box that isn't grounded. We can go ahead and press test and reset. This GFCI works properly, and it is labeled no equipment ground. We previously had 10.1% voltage drop, and we currently have the same 10.1% voltage drop. Here we are at the fifth receptacle on the circuit, and this one is showing open ground, which you expect, and we're going to go ahead and test it and then reset it. So the GFCI works properly. It is labeled no equipment ground, and the previous voltage drop at a 15 amp load was 12.4% voltage drop. This is the sixth and last receptacle on the circuit, and I've had another very pleasant surprise. You can see right here I wrote down no ground, and here it is. It's reading grounded now. So that's really neat. I think it was a self-grounding clip. So we can test it out here. We'll press test and reset. So you see the GFCI works great, and I have no equipment ground. Despite the ground that we did find, that's not a ground that meets today's code. And we had 13.9% voltage drop with the 15 amp load, and this one is now reading 13.5% voltage drop with the 15 amp load. And this one is the very farthest away receptacle from the main panel. So the circuitry and wiring has to go the farthest distance to reach here. So we got a kind of a large voltage drop, but at least it dropped down a little bit, 0.4%, by putting in the new receptacle and making sure all the connections are real nice and tight and so forth.
So now we have a circuit of high quality GFCIs, and these are commercial grade and federal specification grade. They're the Leviton Slimlines, although it's best to change out all the wiring in your home. Sometimes that's just not possible financially. So this is a code approved way to protect yourself. These GFCIs do give personnel protection even when they don't have the proper ground wires. The method that I showed in this video has the advantage of tripping only one GFCI at a time. And the GFCIs will hold your plugs much, much better than those old two-prong devices. I'll put links in my video description for the ideal circuit breaker finder set, the Fluke voltage detector, the ideal Sure Test circuit analyzer, the DeWalt cordless or corded vacuum, which is very valuable for an electrician who needs to vacuum while the electricity is off, Wago lever nuts in the 2, 3, and 5 connector sizes, as well as the variety packs, Leviton Slimline GFCI receptacles, which are 25% slimmer than other brands, and last but not least, Leviton Decora receptacles. Thanks. I hope this video was helpful.